Hi, mathletes. Today we're going to find unknown angles using variables, and we're going to use algebra to solve angle problems in triangles and in quadrilaterals. So today's video, we're going to focus on exploring how algebra helps solve geometric problems. We're going to use variables to represent unknown angles. We're going to apply angle rules in triangles and quadrilaterals, and we're going to strengthen your problem solving and reasoning skills. So this is your chance to see how algebra and geometry work together to solve these types of problems. So here's our first problem. We're going to try to find the angles in this quadrilateral. So we have to think about, what do we know about quadrilaterals? And we know that the sum of the angles always equal 360 degrees. So let's add our four angles together. We have our blue one, which is 4x, the red 2x, the pink 3x, and the green 6x. Let's combine our like terms, and we have a total of 15 x's. So 15x equals 360 degrees. Divide each side by 15, so x equals 24 degrees. Now we're going to replace each one of the x's with 24 degrees. Let's start with the blue angle, 4x. So 4x, we replace the x with 24 degrees, so that means that the blue angle is 96 degrees. Now let's look at the red angle. Again, replace the x with 24 degrees, and the product of 2 and 24 is 48. So the red angle is 48 degrees. Let's look at the pink one, 3x. Again, the product of 3 and 24 degrees is 72. So the angle is 72 degrees. And lastly is the green angle, 6x. The product of 6 and 24 degrees is 144 degrees. If we add those four angles together, we will see that the sum is 360 degrees. Now let's look at this triangle. And what do we know about triangles? Well, we also know that the sum of the angles in a triangle are 180 degrees. So let's add our three angles together. What we'll need to do is combine like terms. So I combine my e's together and I get 7 e's. And our constants, negative 18 plus 9 is a negative 9. Again, we're going to isolate the variables, so let's add 9 to each side, and 7e equals 189. Divide each side by 7, and e is 27 degrees. So that means that the green angle E is 27 degrees. Now let's replace our other e's with 27 degrees. We'll start with the blue, 2e minus 18. Again, replace the e with 17 or 27 degrees, and the product of 2 and 27 is 54. The difference of 54 and 18 is 36. So the blue angle is 36 degrees. And let's look at the red one, 4e plus 9. Again, replace the e with 27 degrees. And the product of 4 and 27 is 108. And the sum of 108 and 9 is 117 degrees. If we add 36, 117, and 27, we will get 180 degrees. Now let's look at this one. For this one, I notice that I have this angle and this angle, but I don't have any information about this angle ABC. But what I did notice is that they have these tick marks, and that means that the length of BC is equivalent to the length of AB. And that makes it an isosceles triangle. And in an isosceles triangle, opposite angles are also equal, which means that angle BAC is equivalent to angle ACB. That means that the red angle equals the blue angle. So now we can isolate our variable x by subtracting 2x from each side. And I get 7 equals x minus 10. Add 10 to each side. So that means x equals 17. So I can replace both of my x's with 17. Let's start with the red one. So angle BAC is 2x plus 7. Again, replace the x with 17, and the product of 2 and 17 is 34, and the sum of 34 and 7 is 41. Now, angle ACB should also be 41 degrees. Let's check it to make sure. Again, replace the x with 17. The product of 3 and 17 is 51, and the difference of 51 and 10 is 41. So it checks out. So now we have to figure out our last angle, angle ABC. And in order to figure that out, we know that the sum of the angles in a triangle equal 180 degrees. So let's add our 41 degrees, and then if we add angle ABC, we would get 180. The sum of 41 and 41 is 82, and I subtract my 82 from 180, so angle ABC is 98 degrees. Now let's look at this one. What are some things that we noticed? Well, I see that we have a set of parallel lines, and I also see that there are two transversals going through those parallel lines. So let's start with this one, the red angle and the blue angle. And I know that when two parallel lines are intersected by a transversal, alternate interior angles are equal. In other words, the red angle has to equal the blue angle. So think of this as angle BCE and angle AEF. So again, 4x plus 21 equals 7x minus 3. Let's isolate our x. So we're going to subtract 4x from each side. 21 equals 3x minus 3. Add 3 to each side, and 24 equals 3x. Divide each side by 3, and we've isolated the x. X equals 8. Now I can replace every x with 8. Let's start with the red one. The red one is angle BCE. So we're going to, again, replace the x with 8. And the product of 4 and 8 is 32. And the sum of 32 and 21 is 53. Now let's look at angle AEF. AEF, which is 7x minus 3. Now remember, it should also be 53 because alternate interior angles are equal. Again, we're going to replace the x with 8. 7 multiplied by 8 is 56. And the difference of 56 and 3 is 53. So it checks out. Now let's look at our other two angles. We have the pink angle and the green angle. Again, I notice that I have a set of parallel lines and I also have a transversal here. And what I know about that is that interior angles on the same side of the transversal are supplementary. In other words, if I add them together, they equal 180 degrees. So let's put the pink angle and the green angle together. Again, we're going to combine our like terms. So I get 19y plus 9 equals 180. I subtract 9 from each side, and 19y equals 171. Divide each side by 19, so y equals 9. Just like what we did previously, we're going to replace each y with 9. So let's start with the pink one. 9y plus 1, replace the y with 9. 9 multiplied by 9 is 81, and the sum of 81 and 1 is 82. Let's look at the green one. 10y plus 8. Again, replace the y with 9. The product of 10 and 9 is 90, and 90 plus 8 is 98. And just to make sure that this works, 98 plus 82 is 180. So it looks like I didn't make a mistake. Let's find some more angles. Let's see. What about angle BCA? That's this one right here, BCA. Well, I noticed that if I add it to 53, it makes a straight line, which is a straight angle or 180 degrees. So angle BCA plus my 53 is 180 degrees. So let's subtract 53 degrees from each side. So therefore, angle BCA is 127 degrees. Now let's find the purple one, angle ADB. There it is. And what do we know about that? Well, I noticed that it's a vertically opposite angle, and it's vertically opposite from the pink one, which is 82 degrees. So angle ADB must equal 82 degrees. Let's find one more. All right, the orange one, angle DFE. There it is. And what do we know about angle DFE? Well, I noticed that again, we have the parallel lines and it's intersected by a transversal. And alternate interior angles are equal, so it is equal to also 82 degrees. So angle DFE is 82 degrees. Now let's find the area of a rectangle. And in order to find the area of a rectangle, I need to know its base and its height. So what do we know about rectangles? Well, we know that opposite sides are equal. That means that x plus 4 is the same length as x minus 1. So we can say that they're equal to each other. Let's isolate the variable x. We subtract x from each side, so 4 equals x minus 1. Add 1 to each side, so x equals 5. Now we can replace every x with 5. So 4x plus 4, again, replace the x with a 5. So the sum is 9. So that means the length of the blue side is 9. Now the red should also be 9. Let's check to make sure. 2x minus 1, again, replace the x with 5. The product of 2 and 5 is 10, and the difference of 10 and 1 is 9. So it checks out. So now we know the base. Let's figure out the height. 11 minus x, and again, we can replace the x with 5, and the difference of 11 and 5 is 6. So the height is 6. This side, of course, is also 6. So now let's find the area. We replace the base with 9 and the height with 6, and the base, again, the area is 54, so we say 54 square units. Now let's find the perimeter of this triangle. So what do we know about it? Well, I notice that these angles are equal. So if these angles are equal, that means that the sides have to be equal in length, which makes it an isosceles triangle. So 2x plus 17 must equal 5x minus 25. Let's isolate the x. We subtract 2x from each side. 17 equals 3x minus 25. Add 25 to each side, and 42 equals 3x. Divide each side by 3, and 14 equals x. Again, I can replace each x with 14. Let's start with the green one, 3x minus 20. Again, replace the x with 14. The product of 3 and 14 is 42, and the difference of 42 and 20 is 22. So the length of the green side is 22 units. Now let's look at the blue side. I have 2x plus 17. Again, replace the x with 14. The product of 2 and 14, 28. And the sum of 28 and 17 is 45. So the blue side is 45 units. Now, because it's an isosceles triangle, the red side should also be 45. But let's check to make sure. 5x minus 25. Again, replace the x with 14. The product of 5 and 14 is 70. And the difference of 70 and 25 is 45. So that checks out. And now we need to find the perimeter. Remember, perimeter means the distance around it. It has that word rim in it. So we're going to add the 3 sides together. So 22 plus 45 plus 45. And the sum is 112 units. So now you can use variables and equations to find unknown angles. You can apply angle sum rules with confidence. You can recognize important geometric relationships like supplementary, vertical, and alternate angles. And you can approach geometry problems with structured and logical method. Yay, you've developed a powerful tool set for tackling more advanced geometry with clarity and confidence. Thank you so much for watching. If you liked the video, click the like button, leave a comment, and if you haven't yet, please subscribe. And if you have subscribed, thank you so much for watching.